So there's nothing here that's secure. So it'll be recorded and put out on the YouTube channel in case you want to come back and look at it. But I basically tried to pick some questions I thought would be good coming up on the exam, like good thinking and, you know, how to approach it, that kind of thing. So periodic table, as always. Your reference sheet would be great if you've got the reference sheet handy. Let's see what else. Maybe a calculator, because some of it's FRQs, things like that, and you'll get a chance to answer the questions as well. Welcome, Mr. Poe.
Yeah, I see Mr. Ballinger's in here and Miss Gassinger's in here too. So
you're right. Yeah,
we got a motley crew of folks here today.
Motley crew. That's nice. I get to be Nikki Six. Y'all don't even know who that is.
So I would have never come up with that.
You can look at it later. Motley crew. That's funny. I was just looking to see if Mike had anything Auburn related.
No.
Jennifer still looks like she's off in the Tuscan countryside.
Yeah.
Oh, there's something about that thing in the back. So
that's right. Makes me happy. Good evening.
There you go. Hey, whatever makes you happy. So
that's right.
All right, everybody, at 7 o'clock, let's go ahead and get cranking. As always, if you have questions, please throw them in the chat box and we'll try to answer them as we go. And I realized in the last couple of these, I didn't even introduce myself. So I am Danny Elegante, and I have taught AP chemistry for like 14 years. And so I retired from teaching in 2020, but I taught for a really long time. So 27 years total. So the goal of tonight is just, let's get better. Wherever you were at, however much content you covered, the test is coming up in a little bit, right? A couple days. So no stress. Just try to be better at the end than you were today. Try to cross some things off your list. Like if I give you a question, you're like, I got this. Cross it off your list. You don't need to study that anymore, right? So it's kind of an approach to some questions, doing what we're doing, and a way of thinking about the AP chemistry exam. Just how can we be better? And then this will be recorded in case you want to go back and watch it again. In case you have trouble going to sleep one night, you're more than welcome to do that. So let's go ahead and get cranking. There's lots of people on this, but not very many people in Pear Deck. So there's like 18 people on the call, but only 9 people in Pear Deck. You're going to want to be in Pear Deck because of this, right? Because of this right here. You guys get to pick which hat I'm going to wear. So every single one of these extra sessions we've done, I've been wearing a hat. So y'all go ahead and pick. So use Pear Deck, and I have a lobster hat, a cow hat, and a hot dog hat, and you guys get to pick. Matthew, you might want to go ahead and mute your video if you want, man.
All right, sir.
No problem. No, you're good.
You want me to mute up as well?
Oh, yeah, the audio is fine. That way, if someone comes in the background, I just, typically we don't throw a lot of video on here just because of, you never know when someone's going to come walking in, that kind of thing.
Yeah, I get that.
Yeah. All right, so let's see. I've got 9 of 11 responses. So let's see how the voting's going so far. So, ooh, cow is winning, but not by a lot. Lobster is a close second.
I wanted you to wear a hot dog hat, man. You would have looked so good in it.
All right. Well, Matthew, if you go ahead and mute your audio for me, please. And then everybody on Pear Deck, you guys get to vote. I'm going to close it down in just a minute. It really looks like cow's working. Working and winning, so. All right. So it looks like, okay, cow's the big winner. So let's get moving. Let's get moving. Yeah, moving. All right. So this is a multiple choice question I pulled from 2012. So here's what I want you to do. I'm going to give you 20 seconds of think time. So just think like, how would I approach this question? Ready, set, go. All right, so that's 20 seconds. So on the AP exam coming up on Monday afternoon. So think, can I answer this question in 30 seconds? If you can, boom, knock that sucker out. If you can't, then you might consider leaving it, coming back later, and then going, what's the answer? We want you to see every single question. So I usually tell my students, give it a good 20 or 30 seconds. If you think you can give it answer it in 20, 30 seconds, then go ahead and knock yourself out. Otherwise, you might want to wait and come back to it later. So these were my thoughts, because I didn't look at the answers to these, right? I just looked at them just like y'all would. And I thought, is this a good thing for students to go over? So this is what I came up with. So rate, I hear rate, and I think kinetics, right? Because then whenever I hear rate, but it's not asking me to write a rate law. It's not asking me about rate determining step. It's not asking me about a value for K. So I don't know if it's really kinetics, but whenever you hear rate, you're like, oh, kinetics, right? And then I looked at the balance equation, and I saw there was a 1x to 2y ratio in the balanced equation, right? So what I would like you to do is go ahead and take, Mr. Matt, if you could throw a link in the chat box. Somebody's asking for the link for the pear deck. Alexander, it's coming out in the chat box, man. So what I want you to do is take 30 seconds or a minute or so and think about what is the question asking you for. And I want you to drag the icon to what you think the right answer is. Okay, so we'll give you a couple seconds. For those of you wondering, tonight, it's all about the peanut M&Ms and some water. So, and a cow hat. I got 9 answers out of 11. There's 22 of y'all out there. So go ahead and join the pear deck. Go to joinpd.com, just in case you've never done it. Joinpd.com and enter that code KZBZKQ, and the directions are in the chat box. I know not everybody has been doing the pear deck thing all along, so go to the chat box on the Zoom, and you can find the directions there. All right, so I'm just going to check y'all's answers real quick. All right, somebody thinks it's up in the question. That's probably not it. So I've got some B's and a bunch of D's. All right, that's all right. Bunch of D's. All right. So let's think about it. There is a 1x to 2y ratio. So what's the question asking for? It's not really about kinetics. This is actually a stoichiometry question. It just looks like a kinetics question because it says rate, and it's like moles per liter per second kind of thing. And it just makes it dresses it up like a kinetics question, when in truth, it's just simple stoichiometry, right? So if X goes down at 2.8, don't even worry about the exponent, right? 2.8, then how fast will Y go down? Well, X is decreasing because, well, X is a reactant, right? So reactants get smaller, products get bigger. So for every 1X, I know that there'll be 2 Ys that disappear. So if X goes down by a factor of, 2.8, then how much will Y go down? Well, it should go down twice as much. So when I do the math, then I say, oh, okay, yes, Y will decrease twice as fast, and the answer is D. So all those of you who said D, that's great. Now, there's some of y'all wondering, excuse me, why is there a choice E on this question? Well, if you're as old as I am, way back in 2012, there were actually 5 answer choices on the AP exam. Starting in 2014, when y'all were oh so young, they actually revamped the exam, and they found that they could get really good data even with just 4 possible answer choices. So the ones that y'all will see Monday just have 4 answer choices, right? So don't worry about there's 5 on these. They're just old. So, all right. let's look at another one. All right, some half reactions. Okay, according to the half reactions, which of the following occurs? So I'm going to give you 20 seconds of think time, right? So read the question, think about, could I answer this or not? So I'll just go ahead and give you all some time. And these are the notes I made as I read through the question. So it occurs, right? So occurs means it's thermodynamically favored, right? And I know that a thermodynamically favored reaction, that the E of the cell for electrochemistry will be positive, right? So when it says it occurs, it doesn't talk about power supply or anything else. So it actually happens, right? So we know that's a positive E. We have to flip one of those equations up top. So either the copper or the chromium has to flip. And the other thing I noticed is the copper is gaining 2 electrons in the equation, and the chromium is only gaining 1 electron. So I know when I balance the reaction, when I write the equation for it, I need to worry about multiplying the chromium equation times 2, right? So we're going to have to multiply the chromium equation by 2, and I know the E has to be positive because it says it occurs. That's how I'm getting to those points. So what I want y'all to do is go ahead and figure out, for the E to be positive, which one are you going to flip? And then go ahead and pick an answer choice that seems the most logical to you, right? Because you got to flip one of them. They can't both be reduced. One of them has to be oxidized. So figure out which one you need to flip, knowing that E has to be positive when a reaction occurs. So those of you, as you're finishing up, this should be one of those questions that you could probably do in 30 seconds, maybe 45. You have a minute and a half on every multiple choice question. This would be hopefully something that you could save some time on, right? So I'm just going to check to see what y'all are saying. Y'all are saying mainly B. Okay, that's good. All right. So hopefully that's right. All right. So this was my thought about it. I have to multiply the chromium equation by 2. So whatever I end up with, I should have 2 chromiums. And that's because if copper is gaining 2 electrons and chromium is only gaining 1, I got to multiply it by 2. So my equation I'm looking for should have 2 chromiums. And there's a couple that do that, right? So here was my thinking about where to find the answer. So I want to flip the chromium equation, because if I flip the chromium equation, the E naught, instead of being negative 0.41, becomes positive 0.41. And then when I add them together, 0.34 and a positive 0.41 becomes positive 0.75, right? If I had flipped the copper and added them together, my answer would be negative. And that's not going to work. So because it occurs, then I want my E naught to be positive when I add them together. So I have to flip the CR equation. And so I want the copper and the chromium 2+ as reactants. And I want the copper metal and chromium 3+ ions are products. So the way I simplified it is the copper 2+ and chromium 2+ are reactants. And the other ones are products. The only one that matches that is B, right? So I just flipped one of the equations and then went, what makes sense, right? So this should be something that that you ought to be able to grab some easy points on, right? All right, let's look at another one. Again, just take a moment and go ahead and I'll give you some read time. So go ahead and read the question. Mr. Poe, I think this is the first time I've ever seen you that you don't have an Auburn something on, unless it's hiding on that shirt. So your shirt looks green though. I don't think you have a green Auburn shirt. This could be a first for me.
Yeah, I'm still at school too, so I can't even go put something on.
Oh, okay. That's a late night. All right, so that's a decent amount of think time. So let's think about, okay, so what do we know about what they're saying? For net ionics, we want to pull apart into ions anything that's a soluble salt. So we know our solubility rules. So let's think about for Monday's exam coming up. Let's think about soluble salts. Anything with nitrate, right? Any of the group 1 metals, so sodium, potassium, like that, right? Perchlorates and chlorates are always soluble. But basically, if you know nitrates and group 1 stuff, that's pretty much most of the solubility rules. So anything that's soluble, we want to pull apart, right? So if it's showing it as an aqueous solution, we want to pull it apart. If it's a strong acid or a strong base, we want to pull those apart into ions. So what are your strong acids? Well, your strong acids are Hickel, Hibber, high, so HCl, HBr, and HI. And then like nitric acid, HNO3, and H2SO4. How do we know that this is a strong base? Because the question tells you. So on Monday, really think about taking your pencil and underlining words like strong base or weak acid, right? To help you identify in your reading what's going on. So any one of those gets separated into ions. So we would pull those apart into ions. Anything that's weak, whether it be acids or bases, or anything that's a precipitate, do not get separated. We leave them together, okay? So what I want you to do is I want you to cross out, by drawing on the slide, I want you to cross out any of the answers that you think can't possibly be right because they're not meeting those directions that I laid out in red. So go ahead and cross out any of them that don't seem right. And then what you'll be left with is either 1 or 2 to guess between, or you'll be left with, this is the only one that makes any sense whatsoever. Make sure you notice in the question that it says it makes a precipitate, right? So I'll let you go ahead and draw on the slide. I just had the thought. Matt, are you recording this? Okay, good. All right. I would hate to get to 8:15 and be like, oh, well, you know. So we did that.
Yeah. I turned it on about 2 minutes in.
Okay. We did that in 2020. We had that whole one that we did. That,
Yep, forgot it until the very end. Yep.
yeah, well, best laid plans. All right.
It happens.
Yep. All right. So, oh, good. We got 17 of y'all in. Good job. So go ahead and keep going. I'm just going to look to see what y'all are marking out. All right. So y'all are marking out. Ooh, that's great. See, this person marked out 3, and then they're down to 2. And they may not know for sure, right? They're like, but if you have to guess between 2 instead of 5, so much better, right? So there's marking. Y'all are marking. Ooh, some of y'all are marking the right answer in colors. All right. It's great. So some of y'all, most of y'all, I should say, most of y'all think that the answer should be something like B or C. Right? Most of y'all are saying B or C. So most of y'all are also saying maybe it's just B. So let's see. I shouldn't I shouldn't keep saying B and C. A lot of y'all are saying B is the answer. Let's see that. Okay, so this is where I went, right? So this was my thinking as I went. A is out because the H shouldn't be separated in water. Water is a very weak acid or base. Water we leave together as water because it's water, right? So we shouldn't just have that going on, right? C is out because it says that sulfurous acid is a weak acid. So it should be H2SO3 stuck together because we don't separate weak things because they don't ionize very much. D is out because D doesn't show any kind of precipitate, right? See how it shows aqueous and liquid on the right-hand side of the equation? So D can't be the answer either. And E can't be the answer because it says it's a strong base, and anything that's a strong base, the barium hydroxide should be separated. So instead of showing it as barium hydroxide together in the equation, it should be separated. Now it does show a solid, yes, but we would want to show them separated. So the correct answer here seems to be B because it keeps the sulfurous acid together, right? A weak acid. It separates into ions, the strong base. It shows the precipitate, barium sulfite, BaSO3 on the right-hand side, and then the water is still stuck together on the right-hand side, right? So B looks like the most, the best answer kind of thing. All right, so here's another one. This comes from equilibrium. So give yourself some read time. Let's see how you do. For those of you late to the game, tonight's snack, peanut M&Ms. For those of you late, you didn't get to pick what kind of hat. You should show up on time because you had a choice between a hot dog hat and a lobster hat. But everyone picked the cow hat. I personally think it's utter nonsense. Some of y'all will get that joke later. So some of y'all are thinking, now that you've had some read time, some of y'all are thinking, why did you pick this question? My students oftentimes forget the simple things, right? They get really tied up in equilibrium and stuff like that. And sometimes the questions are fairly simple. So what I want you to notice is that the first equation where it says K1 and the second equation where it says K2, they can be combined to give us the equation K3, right? So we can add them together. So we can either keep them as is, or we can flip them. And we can also multiply them by anything if we want to, right? So this is what I remember about equilibrium. When we add together equations, we multiply the K value. If you have to flip an equation, we invert the K value. So let's say we had to take equation 1 and flip it, right? Let's say we had to do that. Well, the K, when you flipped it, would now become 1 over 2 times 10 to the 105th power, right? So it would become 0.5, 1 over 2 times 10 to the negative 105th power because we invert them, right? If you have to multiply an equation by anything, you take that K value and you bring it to the exponent. So let's say for equation that says K2, if we had to multiply that equation by 1/2, to make it work, right? Then what we would do is we would take that K value, 7 times 10 to the 24th, and we would bring it to the 1/2 power. Or in other words, we would take the square root, right? Those are the rules that we learn. If you flip it, it inverts. If you multiply it by anything, you take the old K value and you bring it to an exponent. All right. So with that in mind, if y'all could go ahead and do the math that you think you need to do, but keep in mind, you don't get a calculator. On these multiple choice, you don't get a calculator. So try the math just as mental math and see if you can pick out what you think is the right answer and use Pear Deck to choose that right answer. All right, I got 11 of 17 responses. Let's see if we can get a couple more. So I'm just going to start peeking at answers real quick. Ooh, wow. Overwhelmed. Excuse me. Peanut M&M stuck in my throat. Overwhelmingly, y'all are saying A. All right. So, all right. So we don't get a calculator. All right. So let's see. How would you actually do this math? Well, if you look, we don't have to flip K1 or K2. If you look, the SO2 in the first equation cancels out the SO2 in the second equation because one is on the products, one is on the reactants. And then you're left with 2 S's and 3 O2s makes 2 SO3s. So we can just multiply the K1 times the K2 and we will get the value for K3. Now, I don't like complicated math, so I tried to keep the math simple. First, I did just the numbers, not the exponents. So 2 times 7 is 14. 10 to the 105th times 10 to the 24th, that's the exponent part, means we add the exponents together, and that becomes 10 to the 129th. Now I can smush those numbers back together. So 14 times 10 to the 129th is the same thing as 1.4 times 10 to the 130th. And what answer looks even close to 129 or 130? And the answer was A, 1 times 10 to the 130th. So if that was your answer, good job, right? Just keep in mind that sometimes the simple things that we're like, oh yeah, I have to study all this equilibrium stuff. Sometimes the questions are as simple as what you're seeing right now, right? All right, so on to the 2021 FRQs. So these are FRQs from 2021 that were public, right? So there's, in a given year, there's probably 5 different exams. So there's the one most of y'all will take on Monday. We call that the operational exam. There's one called the international exam that they give to international students, and oftentimes they give them to public high schools, or not public high schools, to high schools in the United States. Why do they do that? Because they want to see if the students from overseas are doing just as well as the students from the continental United States, right? They don't count Hawaii. Hawaii is so far away, time zone difference, that they get a different exam typically. But there's the operational, and then there's the international. And then we also have 3 other exams that serve as makeup exams, or sometimes they just use them as like test exams, you know, how are students doing on this? Because there's a couple different makeup days. So you're doing some basic reading right now. And this is the operational exam. So this is one that everybody in the continental US saw last year, and Canada and Mexico. And so go ahead and read it, see what it's saying. All right, so it wants to write us us to write an expression and calculate pH. So here's my thoughts. Here's how I'm thinking I should approach this. K is always products over reactants. Now, when you do a K expression, this is big K, equilibrium, not little k, kinetics, right? It's always products over reactants, but you never include a pure solid or a pure liquid. So we're not going to include the water, right? And then I ought to be able to build an ice table to find my H3O concentration. And then I ought to be able to find the pH by taking the negative log of that concentration. So y'all go ahead and take a minute and write out your answers, type out your answers, and we'll just see how we do. So let's see. Why don't I give you, let's give you 2 minutes to do that part. So that's about 1 minute gone. So go ahead and take another minute to work on it. You got 12 of 18 so far. That's great. All right, so that's 2 minutes. Let's see where we are. So I'm just going to peek at some of your answers real quick. H3O and HCO over HCOH, okay. So if you put water in your K expression, remember you shouldn't have that, right? Because water is a pure liquid. We don't put that in the K expression. So I didn't want to make an ice table because it would take too long. Sure. Okay. Just remember on an AP exam, and I know this is not an AP exam, but on AP exam, if you just throw out an answer without a calculation like showing where you got that answer, you would totally not be given credit. So a lot of y'all are getting 2.17 for a pH. Okay. All right, so far so good. All right, so let's see. What did the answer look like last year for this part of number 1, right? So what you see on the right is that's what they wanted for a K expression. What you see on the left is those were very common misconceptions. So what I want you to do is look at the misconceptions and think about, did I do that? And just on Monday afternoon, don't make that mistake, right? So it's always got to be products over reactants. they gave you the equation, so you have to make sure you show that they're ions. So you can't write H3O if it's an ion. Some people put reactants over products. We know that's a no-no. And some people just left out Ka. So when they want you to write a Ka expression, if nothing else, go to the reference sheet. They wrote a Ka expression for you, and then you can be like, oh, okay, yeah, I get it. I'm supposed to mimic exactly what they did on the sheet. So Ka is equal to the ions of H3O times the ions of HCOO over the ions of over the molecule HCOOH, right? So you would get 1 point for that, right? So that seems reasonable. What about that second part? So for the second part, I know this is kind of small, so just read along with me. Just stay on the right-hand side of what I'm showing you right now. So they put 0.25. Why? Because that 0.25 was the initial concentration. And the other two are 0, because when we do simple acid base, just simple stuff, not buffers or anything else, we start out with some of the acid. The other two are 0, minus X because the reactants go down, plus X because the products go up. And then we combine them, we get 0.25 minus X, X and X. And then they gave you the Ka number, right? They gave you the Ka as 1.8 times 10 to the negative fourth is equal to X squared over 0.25 minus X. Now, if you really like some hard math, go ahead and do the quadratic. But just remember, on the AP exam, you shouldn't get a better score because you have a more expensive calculator. So we're going to say that because the K value is so small, that 0.25 minus X is pretty much the same thing as 0.25. It's called neglecting the X or making the assumption. So then once you do the math, you find that X, which in this case is the hydronium, the H3O concentration, is 0.0067. And the pH is thus 2.17. So that's how you get that second part right. All right, cool. All right, so that was just the first part, right? So let's see, what did the rest of this question look like? So here's part C. So they gave you an acid-base thing. And remember, the acid is HCOOH, right? So the second part is draw a Lewis structure. Now, I'm not going to give you all the directions for how to do a Lewis structure because y'all have done a ton of these. So right now on the Pear Deck, just go ahead and draw what you think the Lewis structure is based on the instructions that they give you. Okay, y'all are doing great, by the way. That's 15 answers out of 18 of y'all. That's great. And think about on the Lewis structure, y'all have probably done so many of these this year. You're just like, oh, I'm so tired of Lewis structures. So I'm just going to start peeking at your answers. But this is a quick and easy way to get a point, right? So, all right. So there's one. Right. So the rule is make sure everybody has 8, right? And make sure you're only spending the electrons that you have. So you might want to look at your periodic table, see how many electrons you have, like valence electrons. Add those up. Make sure you're only spending those. Interesting. So for those of you out there working on this still, let's do a quick math. So carbon's got 4 valence electrons because it's in group 4. Oxygen's got 6. So 4 plus 6 plus 6 is 16. And then hydrogen has 1. So 4 plus 6 plus 6 plus 1 plus 1 is 18. So you should only be spending 18 electrons. Remember, a bond is 2 electrons. And just make sure you're spending only 18 electrons. You're only putting 18 electrons on there. Interesting. Some of y'all are going to make wonderful organic chemists someday. Some of y'all are going to struggle, just saying. When you get to college, you'll understand. All the teachers out there feel me. All right. So I'm just looking through y'all's answers. I see a lot of great answers. Don't forget, on the AP exam, you can either show lone pairs as dots or you can show it as a line. I haven't seen anybody do that tonight, but you can show lone pairs as a line. All right, cool. All right. So this should be something that you can do pretty quickly and get a point, right? So here was the thoughts about looking at it. So remember, the correct answer is on the right-hand side, and some common misconceptions are on the left-hand side. So first, check the right-hand side and see, does your thing look like that? Now, a couple of y'all had a slightly different answer. So let me give you a different Lewis structure that would have been okay. So some of y'all had, on the first oxygen that's on top of the carbon, some of y'all had a single bond there with that oxygen, and then between the carbon and the oxygen on the same line, you had a double bond there. That would totally be okay. You could have a single bond up top as long as it had 3 lone pairs, and a double bond down in the HCOH part, but the oxygen could only have 1 lone pair. So some of y'all did that. Some of y'all drew that. That was totally fine. It is not the answer we're expecting because of formal charge. Formal charge works better with the answer that I'm showing you right now. But you know what? They didn't say make sure you do it according to formal charge. So as long as everybody saw 8 electrons, except for the hydrogen, I know, and you spent all the electrons, then you'd be okay. But if you look on the left-hand side and look at the common misconceptions or common errors kind of thing. So some people, that very bottom one, had way too many electrons going on. So they had a lone pair around the carbon. And that's, you're just spending more electrons than you should. So carbon had 4, each oxygen had 6, and each hydrogen had 1. So add them all up. That's how many you get to spend. The top one actually violates the octet rule. The oxygens are okay. The hydrogens are okay. But if you look at that carbon on the top left-hand side, it only sees 3 bonds, which is 6 electrons. So while all the electrons are there, they're just, you're not making the carbon stable by giving it those 8 valence electrons. Cool. All right. So let's see, what did part D look like on this particular question? So they gave you an acid base thing. They gave you a Lewis structure. Then they said, okay, the compound, whatever this compound is, reacts with water. And we know it's a base because it absorbs an H or it gives off an OH ion. And it gives us a Kb value, right? So we know that the H2NNH2 is a base, right? Because it's absorbing an H, creating that conjugate base acid pair, right? And it's giving off OH ions. Now, they combine a 50 milliliter, 0.25 molar solution with a 50 milliliter, 0.25 molar solution of the acid from before. So that HCOOH, that was the acid that we did in part A, B, and C, right? So they're just adding to the problem that we have. So write the balanced net ionic equation. And then for part II, is the resulting solution acidic, basic, or neutral? So let's think about, what do we know? Well, we already talked about net ionics. So we only pull apart strong acids and bases. And the K values are pretty small, 1.8 times 10 to the negative 4th, 1.3 times 10 to the negative 6th. That means those are fairly weak acids and bases, right? We also know from the reference sheet that Kw is equal to Ka times Kb. So look at your reference sheet if you need it. Kw is 1 times 10 to the negative 14th. And so if you know the Ka for HCOOH, you can figure out the Kb for the HCOO, right? So think about when all of the reactant turns to product, because you're adding 50 milliliters of 0.25 molar. So there won't be any like excess reactant. You're adding exactly the amount of one chemical to react with exactly the amount of the other chemical. So there will only be products, right? So we know that we can compare Ka versus Kb's to know which is stronger. So if you can figure out the Kb for the HCOO ion, and if you can figure out the Ka for the H2NNH3 ion, then you can compare them. The bigger the number is, the stronger it is, right? So go ahead and write your response for part I, where you write the net ionic equation, and go ahead and guess as is it acidic, basic, or neutral. And remember, justified means you have to do something. You can't just guess acidic or neutral, right, or basic. So you have to give some reasoning as to why that's true. And the reasoning should be based on evidence or data. And the data is in those Ka and Kb values. So if you will go ahead and take a moment and write out your response. So I've got 10 answers so far. That's great. So just in case you're wondering, like, how long would I get on this entire question? So on this whole question, this was number 1 last year. You would get 22, 23 minutes, something like that. So if you're a little bit slow at working, you may even want to consider to go to the end and do question 4, 5, 6, and 7. Do the short questions first, right? Just to make sure you don't get stuck on the long question. You want to make sure you answer every question, right? So if you're kind of a slow worker or a slow reader or something like that, you may even want to like jump ahead to the short ones. And don't worry, I've got a couple short ones for y'all to see. But right now we're just on part D. And I've been showing y'all along like how you get the point. So I want y'all to kind of be thinking like, how many points would I have gotten so far? Did I write the Ka expression right? Did I get the pH right? Did I draw the Lewis structure right? For part D, am I going to get any of these points kind of thing? So let me just start peeking at y'all's answers. So don't forget that when you write out net ionics, that you need to be showing things as ions if they're ions, right? So when you go back and look at those original equations, make sure that you're doing that, right? So that H2NNH3 needs to be shown as an ion. So just make sure you're doing that. And the OH needs to be shown as an ion. The H3O needs to be shown as an ion. So be thinking about that. Right. So I'll give you like another minute. Let's go ahead and type out the answer that you think you can. What I want you all to realize is part I, the balanced net ionic equation, that's the same number of points as part II, right? So don't be thinking about, oh, I can't do this, I'm going to fail. Do the parts you can, right? Because all the points add up at the end. So just because one question is hard doesn't mean that you're not going to pass the exam. It just means that's going to be hard for lots and lots of people. All right, I'm still here. I'm just giving y'all a little bit more think and work time. And I want to make sure we get to the short one. So I'm going to go ahead and move on. What did the answers look like, right? What were they looking for? So again, on the right-hand side, that's what they're looking for. That's the net ionic equation they're looking for, because you're kind of putting them together, right? You're leaving the H2 and NH2 together because it's a weak base, and you're leaving together the HCOOH because it's a weak acid. And if you look over on the left-hand side, you see some of those common errors, right? So you forgot to write that things are an ion, right? That would not get you credit. Or you're using the H and the OH as a reactant, because remember, the H and the OH kind of go away because you're making water. And we know that weak things, we don't show them as giving off OH ions, or we don't show them as giving off H ions. Then the second part, I really think this is almost the worst part. Part G, subpart II, is almost the hardest part of the question, right? The overall answer is acidic, because the Ka of the base, remember, the question asks you for, it gives you the Kb for the base. So you have to find the Ka of its conjugate acid. And it tells you the Ka of the HCOOH, and you have to find the Kb of its conjugate base, HCOO. And then you compare the two, right? So a very common answer was to compare the numbers 1.8 times 10 to the negative fourth and 1.3 times 10 to the negative sixth. That didn't get you any points, because those were the K values before they reacted. And after they reacted, we're left with conjugate acid and conjugate base. And that's when you're kind of trying to determine what the pH is. So the answer was acidic. If you didn't get that point for part D, subpart I, you know what? That was a hard question, right? So let's just, is this the question or was there more? Ooh, more. All right. Is the reaction a redox reaction? Because when a catalyst is added, the reaction represented by the following equation occurs, right? So what do I think? What is a redox reaction? How would I approach this problem? Redox has to do with oxidation numbers, right? You guys should have seen this a lot. There was one on the mock exam. So what you want to do is assign oxidation numbers and look to see if they're changing. If they're changing at all, then it's a redox reaction. So let's go over the rules one more time for oxidation numbers. Hydrogen in a compound, right? So HCOOH. Hydrogen's a +1. Oxygen's a -2. And then carbon is whatever it takes to make them all add up to 0. For hydrogen, H2, that's an element all by itself. An element all by itself has an oxidation number of 0. And then for the carbon dioxide, the oxygen's a -2, and the carbon is whatever it takes to make it add up to 0, right? So go ahead and write your response. Is it a redox reaction? Or your first word should be either yes or no, and then use the data, because you're assigning oxidation numbers. Use the data from the oxidation numbers to justify your answer. If the oxidation numbers change from the left-hand side to the right-hand side, then it is a redox reaction. All right, so let's see what y'all are answering real quick. No, because there's no change in oxidation number. So even if you said no, there's no change in oxidation number, that's fine as an answer. You need to tell me that you know what the oxidation numbers are. So if you think they're the same, then you need to be saying oxygen on this side is this and oxygen on that side is that, right? Yes, the oxidation numbers are changing. Notice hydrogen's oxidation number is 0, but notice hydrogen on the right-hand side is 0. But notice this person never said, oh, by the way, on the left, it's whatever. So you got to tie it somehow to that the oxidation numbers on the left are different from the oxidation numbers on the right. The hydrogen charge goes from +1 to 0. And again, you might want to fill that answer out a little bit more. It's +1 in this molecule, it's 0 in this molecule. The carbon is going from +2 from +4 from reactants to products. Again, maybe instead of going from reactants to products, it's +2 in this molecule, it's +4 in this molecule. You're just trying to make it very clear to the reader that you know what you're talking about. The H is +1 in HCOOH, in 0 on the product side. That's good. They're referencing each individual molecule. That's good. Y'all are changing your answers. That's why I'm trying to read them. That's great. Okay, so if you said yes, C is oxidized and goes from 2 to 4, you really need to say it's +2 in this molecule and it's +4 in this molecule, right? To gain the point, you really want to show that you understand the oxidation numbers. Okay, so let's see, what did they take as an answer this particular year, right? So yes, the answer was yes. The only acceptable answer was yes. The oxidation number changes. So in HCOOH, H is a +1, and hydrogen on the right-hand side is 0 because it's hydrogen, just a molecule, just hydrogen. Or you could have said that the carbon on the left-hand side is +2, because remember, all the oxidation numbers have to add up to 0 in HCOOH. And on the right-hand side, the carbon is a +4, right? So that's the correct answer. You could use either one to get that point. So what were the common problems? Let's see, did you make one of these? Claiming that decomposition is always redox. Well, I didn't see anybody do that, so that was okay. It was reduction or oxidation without actually using evidence, right? Using the numbers, the oxidation numbers, or assigning incorrect oxidation numbers. So even if you said carbon's a +5 and it goes to a +4, if you had gotten it wrong, then you probably would not have gotten the point, right? So what does that mean coming into Monday? What that means is just look over how to assign oxidation numbers. That's a pretty easy skill that you can look up. Now, part F, I'm not going to show you, but part F was basically was a PV equals nRT problem, right? So they wanted to calculate moles given pressure and stuff. Y'all can do that. I totally get that. You would get a point for that. And then they said, oh, by the way, we're adding a catalyst. Does the amount of catalyst increase, decrease, or remain the same? Justify your answer. And the correct answer there was a catalyst is not used up in a reaction. So the amount of catalyst would remain the same. Point. Boom, you got a point. Now, here's the scary part. That is a 10-point question. And on a 10-point question, the average last year, 3.9. So if you found, even though I didn't show you the last part, if you found that you could get 4 points, y'all are killing it. If you can get 6 points on this question, awesome for you, right? Now, if there was one part that you're like, oh, I forgot about that. Don't beat yourself up about that. Think, okay, that's something I need to work on before Monday, right? That's something I need to ask my teacher about tomorrow, right? Okay, so let's look at one of the short ones real quick. So this is Electrochem, which is unit 9, right? So hopefully y'all done this recently. So I'm going to give y'all a minute to read the actual question. And I'm going to eat my last M&M. So, excuse me, going through puberty all over again. For those of you wondering, like, how many points is this? Remember the short ones. So 1, 2, 3 are worth 10, and 4 through 7 are worth 4, right? So those short questions aren't just like throwaway, like, oh, I'll do the long ones. The short ones are just as important, right? You got 4 pointers at 16 points, right? So you want to make sure that you do those as well. So what do we have to do? We have to draw an arrow. Y'all, this is you draw an arrow, and it's either you draw an arrow to the left or to the right. It's a 50-50. You don't even have to like justify your answer. You just draw an arrow, right? Would an applied voltage of 2.0 volts be sufficient? Support your claim with a calculation. If the current in the cell is kept at 5 amps, how many seconds does it take to produce 2 grams, right? So this is what I think about when I look at those questions. If it shows up, hang on. I want to use the picture to find evidence. See how there's bubbles of Cl2 being made? That means I want to take that second equation and flip it so that Cl2 gas gets made. Notice how there's a puddle of magnesium liquid on the top, right? I want that first equation to remain the same because it's making magnesium metal, right? So I'm using the picture to help me understand what to do. Now, once I flip the second equation, then I add the voltages together. So I flip the second equation. Instead of positive 1.36, it becomes negative 1.36. Right? I know this is not a galvanic cell, it's an electrolytic cell because it says power source, right? So we can flip the second equation, add them together to get the, E of the cell. And then the other thing to keep in mind is that very last part about C, what they're asking you to do is do some math. So in amp, when it talks about amps, that's the number of coulombs per second. And a volt, when it talks about the E of the cell, right? Volt is joules per coulomb. So don't forget that when you do the math, you need to think about that an amp is coulomb per second and a volt is joules per coulomb. So I'll go ahead and give you all the chance. Go ahead and write your answers. to this question number 5 right here. And check out the chat box if you didn't see it already. Mr. Matt has posted that there's lots and lots of videos out there from advanced placement getting you ready for the AP exam. So if you haven't seen those, you need to check them out. And the A+ College Ready has a whole bunch of videos as well. And some of them are better than others, but at least in this one, I'm wearing a hat. So that's going to make it better. But go ahead and check those out as well. As y'all write your response, you can be thinking, yeah, I'm going to check out those YouTube channels later. As y'all are answering questions, y'all may be like, how does Danny pick? How does Mr. Elegante pick which question? Well, this particular question last year, the average was 1.1 and 42% of all the answers were 0, meaning they tried to answer it and they got 0 points. And 4% of all the answers were blank. Y'all, that means that, let's see, 4 and 40, 46, almost half of the people that answered this question got 0 points. And remember, one of them is draw an arrow, right? So don't give up. We want y'all to hit these questions. Again, maybe start with the short ones, right? And go, oh, I can do this. Even if you're running out of time, if you got to question number 5 and said draw an arrow, you're like, all right, I'm drawing an arrow to the left or to the right or whatever you want to do. And you might get a point, right? So I'm just going to peek at some of y'all's answers. Then we're going to move on. Arrow to the left, arrow to the right. No, the calculated voltage is 3.73 to the left. So if you say the arrow goes from anode to cathode, I think you're saying from the right to the left, but maybe just you can like draw a left arrow or right arrow towards the more positive one, left to right, left to right. So some of y'all are saying left to right, and some of y'all are saying to the left, right? Sorry, some of y'all are saying to the left, some of y'all are saying to the right. So y'all are all over the place, right? So arrow to the left, left. All right. So what did the answer look like for this particular question last year? Well, we know chlorine is being made, which means we flip that second equation. When we flip that second equation, it doesn't mean that the chlorine is gaining electrons. It means that the chlorine is losing electrons, right? So the Cl2 should be losing electrons, and the magnesium side should be gaining the electrons. So we should be drawing an arrow from the left to the right. So as long as you drew an arrow from the right to the left, right? So from the chlorine side to the magnesium side, you could earn that point, right? Some people, if you look at the common mistakes, some people thought it was voltaic or galvanic, right? And that's not the case because this is power source, right? And some people draw the arrow not up where the wire is with the power source. Some people drew the arrow down in the molten MgCl2. So you didn't have to draw the arrow up top above the liquid line, but you had to, indicate that's the way it was. For the second part, if you add them together, then you get negative 3.73. So you flip the one equation, add them together, you get negative 3.73. So how do you overcome a negative potential of negative 3.73 volts? The way you overcome it is you give a voltage greater than negative 3.73 volts, right? So just like charging your cell phone, for charging it, it's got a negative voltage. And as long as you give it a greater voltage than that, then it will charge. You have to overcome the thermodynamically favorable reaction in order to get it to go the other way. So 2 is less than 3.73. So no, it's not enough to overcome it. So that was the answer. No, because 2 is less than 3.73, right? Now, what about that last part? So this is how you do the math. When in doubt, mole it out. So 2 grams of magnesium, change it to moles. And then from the equation, there's 2 moles of electrons for every 1 mole of magnesium. And so that gives you how many moles of electrons. Now, you didn't have to stop here. You could just keep doing the math. And then that many moles of electrons, use coulombs or Faraday's constant, right? So 96,485 coulombs for every 1 mole of electrons. And then remember how I told you that an amp is a coulomb per second? So 5 amps is 5 coulombs per second. So that becomes the math for how to solve that. And that's how you get 3,180 seconds. Right? So that entire question is worth 4 points. I would hope that you could get 1 or 2 by drawing an arrow and doing either the math down here or by doing the where we talked about in the middle, where 2 is not greater than that 3.73, right? So let me show you one more and then we'll finish out our time. And this is the last review session we'll do. So I just wanted to show you all this real quick. You got calcium sulfate and lead sulfate. The student tests the conductivity of its solids, and neither solid conducts electricity. So this goes back all the way to unit 2, types of bonds. Are they covalent or ionic, right? Metallic. Which ones conduct electricity and which ones don't? So you want to describe the structure of the solids that account for their inability to conduct electricity, right? And then the second part, they place some calcium sulfate in a beaker and some lead sulfate in a different beaker. You stir it to kind of mix it up and then test the conductivity. Some of y'all may have done a lab like this, even in regular chemistry, not in AP. But the conductivity of the solution tells us which one has more ions. And in this case, the calcium sulfate has a higher conductivity than the lead sulfate. So which compound is more soluble in water? So here's what I think about when I think about this question. Metals, we know they conduct electricity. Solutions of electrolytes, so these are salts that do dissolve, conduct electricity because the ions are there. So things dissolved in water do conduct electricity. Metals conduct electricity because they have those mobile electrons, right? The solid does not conduct an electron because they don't have mobile ions that can move around. They're a solid, right? They can't move around the beaker. I noticed that calcium sulfate produces 2 ions, 1 calcium and 1 sulfate. And I noticed that the lead sulfate produces 2 ions. So I'm not even trying to do math, thinking about, oh, this one makes more ions than this one does. They seem to both make the same number of ions. So which compound is more soluble? Justify your answer based on the results of the test. So here's where the answers came in. Ionic solids don't have free-flowing ions. Just go back to unit 2. Just look over covalent, ionic, metallic, right? And for the second part, because calcium sulfate had more conductivity, that means there were more ions present. And if there are more ions present, that means more of it dissolved. So in the world of which one is more soluble, the one that produces more ions means that it is more soluble. Okay, that's those 2 parts. This was the last part. This was the best part. We won't have you do this because we're going to run out of time. But on the left is the calcium sulfate. They told you, they gave you a key of what to do. And on the right, they want you to draw what the lead sulfate would look like. So based on the beaker on the left, they would want you to draw the beaker on the right. So I was going to have y'all do this, but we're going to run out of time. So basically, draw the particles that you would go in there. So look at the number of dissolved ions in the calcium sulfate and think, how many dissolved ions would I put in the on the right-hand beaker, right? So you would draw that, right? And then the second part of the question says, they attempt to increase the solubility by adding sulfate. So think back to equilibrium. Equilibrium, we have this thing called the common ion effect. So if you have calcium sulfate dissolving, it turns into calcium ions and sulfate ions. So if you add sulfate ions, think about which way will that cause a shift? Will that cause a shift towards products, towards more dissolved ions? Or will that cause a shift towards reactants where the solid CaSO4 is? Okay, and then these were the answers they were looking for. You had to have solid PbSO4 at the bottom of the beaker, and you had to have fewer ions. So the beaker on the left had 3 calcium ions and 3 sulfate ions. So on the right-hand side, you just had to have less than that. Their answer shows 1 lead and 1 sulfate, but the correct answer is like, you could add 2. You could add 2 leads and 2 sulfates, still totally okay. But notice at the bottom, they have more ions stuck together as a solid at the bottom than the calcium sulfate. So you still have to have the right number of ions. The key here is to show that more of the ions are in a precipitate at the bottom for the lead sulfate, and more of the ions are dissolved for the calcium sulfate. That was the name of the game. And then the last answer is Le Chatelier's principle. You didn't have to say Q versus K and all that kind of thing. You could have said that adding sulfate, which is a product, a dissolved ion, will cause a shift back to the left, and a shift back to the left will cause more calcium sulfate precipitate to form. So we're going to cause a shift to the left towards reactants, and we'll get more calcium sulfate. All right. So thank y'all so much for coming out tonight. Think about how you did, and think about what you need to work on before Monday and what you were really good at. And now that you kind of know on what you're really good at and what you need to work on, just try to be better tomorrow and try to be better Saturday and Sunday so that on Monday you can kick butt. If anybody's coming to the